Cosec
Cosec
square x.
square minus cosec square x. Okay. What is d by dx of tan x?
Sec square
sec
x.
square x.
6 square x. Okay. Then what is d by dx of sec inverse of x?
1 by x
1
root x
by
square minus 1.
x
1 by x
x.
into square root of
X root
x
x
square
square
minus
minus
1. Clear, right? Okay. So now by using these all properties, we are going to solve the problems. Ready? Okay. Yeah. Right. First of all, first property. See, understanding is very, very important here. Why I'm telling that? When you find the derivative of functions, we have different types of functions. Depends upon the functions only we are using different properties. That means we have chain rule, product rule. Okay. Then if it is composition of functions, okay, composition of functions we are using chain rule. If it is point-wise multiplication, we are using product rule. Okay. And if it is explicit function, directly we can multiply, directly we can find the derivative. If it is implicit functions, what we have to do? Take derivative on both sides. Okay, function is to function, logarithm differentiation, clear? Then parametric form means directly they don't have any connection, they are connected by some parameters, then parametric form, then second order derivatives. So these are the things we are having in this chapter. Got it? Okay, I will explain that, no need to worry about it. Okay, so first you write chain rule. Chain rule. Okay, so listen, understanding is very, very important here. Why I am telling? Uh, 1 minute. Huh? Okay. Do you know where we have to use chain rule? Any idea? When we have to use chain rule?
So when there is a function in function.
Sorry?
So when there is a function in function.
Function in function.
composition of
Yeah.
function.
Okay, okay. Yeah. So, simple example I will give you. Listen, all of you listen here. I have taken two functions. F of x is equal to sine x. Okay. And g of x is equal to x square plus 1. Very easy, simple. Simple. If you can split, when you get the product, if you can split it into two, there you have to use product rule. Example, if I take x square plus 1 into sine x, when the question is x square plus 1 into sine x or sine x into x square plus 1. The question is this one, find the derivative of this function. Is it clear? Now you have to check, do we have two complete functions there? Yes, we have two complete functions. X square plus 1 complete function. Sin x is completed. Here also sin x completed. X square plus 1 completed. If you have these kind of two complete functions when you split, there you have to use what? Product rule. Product rule. Got it? Is it clear? If you can split the given function into two, then that is going to be product rule to find the derivative. Okay. But instead of that, you consider, suppose we are getting the function as like this, sine of x square plus 1. So we are trying to split it. We have many kinds of functions, trigonometric functions, algebraic functions, exponential functions, right? These kind of many functions are there. Inverse trigonometric functions. Okay. So you try to split it. When you try to split, I can see a trigonometric function here, then an algebraic function here. But when I split algebraic function, I get a complete function, but trigonometric function that is incomplete. That means angle is not there, only sine is there. Do you understand? Is it clear? That means this function is not product of two functions. It is also a product, but here we can't apply product rule to find the derivative. These kind of functions are called composite functions. Did you get the idea? Where we have composite function, to find the derivative, we have to use the chain rule. If we have two different functions, if you can split the function into two, there only product rule is possible. Other case you can apply, means when the product is composition, there you have to use chain rule. Both are product of two functions, means in the first chapter you have studied the relations and functions, algebra functions. Okay, what are algebra functions? F of x and g of x are two functions. Then you can write f plus g of x can be written as f of x plus g of x. Clear, right? Okay, then you have studied f of x into g of x, that is equal to f dot g of x. This is point-wise multiplication. It is a type of product. The another product is called composition, that is f composition g of x. Both are products. This is f dot. This is point-wise multiplication. If you are not getting, just note it there. Okay. F dot g of x is point-wise multiplication. F composition. It is not too small. That means little bit bigger than dot and smaller than o or zero. Clear? Okay. So this we read as composition. F composition g of x. This is also a product. Composition. Okay. Now I will tell you how to consider composition. This is a topic from your first chapter, relations and functions. You are getting a note, all of you. Is it clear?
Yes, sir.
Okay, yeah. See, I'm defining a function f from set A to set B. Okay. So there are many elements in this set. Let us consider the element in the set as x. Okay. And here, image of x.
I think something happened.
My God.
आयुष आज लेट के पढ़ रहा है कैमरा में ऑन किया धोनी
Hello.
धोनी सुबह से
Power
पढ़ाई
is
थी भाई
out. Actually. Just a minute.
वो मेरे को कहता कि मैं घर में क्लास कर रहा हूँ उसके बाद जाऊंगा धोनी बहुत हरामी है यार
धोनी
मैं क्या
लेसन
करता,
मेरे
घर
से
पे वो
चढ़ा हुआ
काम
था।
करने वाली आ गई थी, शोर हो रहा था, फिर आ गया मैं।
फिर को बताता हूँ मैं पता
हाँ, धोनी
सुबह 5 बजे का गया वही 4 बजे का
वही ना इसका चढ़ा होता है ना, वो सीएसएन स्पीकिंग में रात को 10-11 बजे वापस आता है, सम ही इज कुकिंग समथिंग।
हाँ
Is it clear, all of you?
यस सर
Okay, yeah. Okay, please do one thing. All of you, please switch on your camera. Is it possible? Yeah. How, Pankaj? Vanish, Avardhan, Krish,
सर
set. Avardhan, Krish.
सर 1 मिनट।
Okay, set. Yeah. Okay. See, listen. Ask if there is any doubt. Okay. Yeah. Listen. F is a function we are defining from A to B. Okay. Then consider in the first set elements are of the form x only, x1, x2 like that. Why x1, x2? That is your domain. What we are substituting, what you are giving, that is called a domain. Clear, right? Okay. So here the elements are x only. Its image you are going to get in the second set. So you can write that image by function of x. Example I will give you. Suppose if f of x is equal to x square. You are giving one element from here. Element is 2. Okay. So f of 2 that is equal to 2 square, which is 4. So where you will get 4? 4 is image of 2. Correct, right? So 2 we are taking the first set. Image we are getting in the second set of 4. So this 4 is what? F of 2. So that's why you can write this as x is an element in the first set. Its image you will get in the second set. That is f of x. Is it clear? Or you can write this is an element in the second set. In second set elements are of the form range. That's why y. F of x or y. Is it clear? Understood? Got it? Okay, tell me.
Yes, sir.
Okay.
Yes, sir.
So x is an element in the first set. Its image you got in the second set, that is f of x or y. Now I am defining another one function from B to C. Okay, B to C. C is another one set. Okay, yeah. So tell me what is going to be the image you are getting in the third set C. Can you say? In the first set elements are of the form x. The function that I defined, that was f. That's why I got the image as f of x. So f of x is same as y here. Clear, right? Okay. In the third set, when you define g, consider in the second set elements are of the form f of x or y. So how to define the function? Tell me.
G of f of x.
G of y.
Very good,
G of
very
f
good.
of x.
G of f of x, or shortly you can write g of
G of
y.
y.
Correct, right? Okay. Now listen what I'm going to say. F is a function we are defining from A to B. G is a function defining from B to C. Then the function we are defining from A to C is called a composite function. And this composition is G composition F. Not F composition G, G composition F. Why? I will tell you the reason. Here you got G of F of X. So G of F of X is G composition F. Okay? Easily you can identify that. Here consider which function you defined second. That will come first here. See, G is the second function, so we are writing G composition. Suppose if define G first, F second, then that is going to be F composition G. Very simple, easy. I'll tell you by one example. F of x you consider sin x. Earlier we have taken G of x is equal to x square plus 1. Okay, if you have any confusion or doubt, you can just do with me, so you'll get it clearly. Is it clear, all of you, this one?
Yes,
If you
sir.
want, just make this diagram.
Okay.
Why I'm telling switch on your camera means then it will be an interactive section. Okay. Otherwise, I don't know what you're doing. Okay. If I can see your face, then that would be better. Completed. Pankaj, is it clear? Sorry.
Pankaj, your mic is not on.
Okay. Yeah.
Yes, sir.
Okay. Now, see how I am going to solve this one. G composition. Suppose if I am taking here G composition f of x. G composition f of x, I can write G of f of x. Clear, right? Okay. So very simple, easy. How to write G composition f of x? G of, just to substitute the value of f of x here. F of x you got sin x. Okay. Now consider G of x. G of x is x square plus 1. G of 1 is 1 square plus 1. You know that in smaller classes, polynomial functions or polynomials, you know that how to find the value of the polynomial. So G of 1 is 1 square plus 1. Okay. G of 2 is 2 square plus 1. So G of sin x is sin x the whole square. That is sin square x plus 1. See, composition. Got it? Understood? It's a composition of two functions. Now, if I take f composition g of x, I can write this as f of g of x. Okay, that is equal to f of nothing is there. Just substitute the value of g of x. G of x is x square plus 1. Now it is of the form f of x. Whatever things you have in the bracket, you consider that all as x. So f of x. What is f of x? F of x is sine x. F of 1 is sine 1. F of 90 is sine 90. So f of x square plus 1, that is sine x square plus 1. See, that we have written earlier. Composition. See, if I split, I am not going to get a two complete functions there. This is a composition. If you have these kind of functions anywhere, so do you understand how to identify this, the given function is composition or not? When you
Yes, sir.
split, we are not getting complete functions, or the functions are incomplete. They are the part of composition. Got it? Okay. Now,
Yes.
to find the derivative of these functions, we are using chain rule. If there are two complete functions, you can find it by using product rule. Do you know product rule, all of you, clearly? Any doubt?
No, sir.
Should I explain product rule? Tell me if you want.
No, sir.
Clear. Okay. Yeah. Okay. So, right. Chain rule. Can I clear this?
Yes, sir.
Okay. Right. Chain rule. So, what is chain rule? In easy way, I will explain dy by dx. That can be written as d by dx of t, or dt by dx, dy by dt into dt by dx. Okay, dy by dx is equal to dy by dt into dt by dx. Okay, what is t here? T is the part in the composition. Just note it there. Very easy, simple. Note that. Okay, yeah. See, two different methods are there. Two different methods, and the second one is going to be easy for you. Okay, always try to follow second method. I'll tell you that. Consider the same question, sine x square plus 1. So you can write the given function either y is equal to, or I told you f of x is equal to. Both are same. Y and f of x both are same. So we can write the given function as sine x square plus 1. Now, consider both the functions are trigonometric function is here, algebraic function is here. Both are incomplete functions. So, what we have to do, the last part you take as t variable. Okay, so I'm writing let t is equal to x square plus 1. Got it? T is equal to x square plus 1. So, if I take t is equal to x square plus 1, y can be written as sine t. That's or not? Is it right? The last one you take as t, then the function y can be written as what? Y is equal to sine t. Now what we have to find? Derivative of y with respect to x. Okay. So how to find derivative of y with respect to x? I'm starting dy by dx is equal to, okay. How to write? Consider start from y. Why we are calling it as chain rule? We are starting with y, end with x. Okay, so these are showing connections. Simple or not? Understanding or not, all of you?
Yes, sir. Yes, sir.
Yes, sir.
Okay. We are starting with the y. So how to start it with y? Y contain variable t. So if you want to differentiate y, you can differentiate that with the t only. Okay. So dy by dt. Now go to t. T contain variable x. So dt divided by dx. This I have written here. Getting or not? Okay. You have to differentiate the function y with respect to x. Okay. So in composition, when you give substitution, you get y which contain variable t. So we can differentiate y with respect to t only. Then go to t. T contain variable x. So dt divided by dx. Okay. Yeah. In the next step, just give value. d by dt of what is the value of y? Y is sine t into d by dx of t. T contain variable x square plus 1. Got it? Understood?
Yes, sir.
Okay. Yeah. See, another one important thing. These two variables are same only, completely you can differentiate. Suppose here it is t, here it is x, you can't differentiate completely. Here x, both are same. Then only you can completely differentiate. Now what is going to happen here? Check it. Derivative of sine t, you know that sine t, derivative sine t, cos t, right? Derivative of x square plus 1. Derivative, some rule you can use. Derivative of x square is 2x plus derivative constant is 0. So you got the answer, final answer 2x into cos t, resubstitution. T is x square plus 1. Okay, this answer. Understood?
Yes, sir.
Okay, okay. So this is actually concept, but some more easily you can solve this. If you want, just note it there. The second method also I will explain. So I think that will be easy for you. This is a general condition, clear, getting? This is the way you have to split it. Do you complete all of you?
Yes, sir.
Yes, sir.
Okay, ready? Okay. See, the second method, function you got first of all, y is equal to sine x square plus 1. Okay. What is the question? Find the derivative of the function. Derivative means dy by dx you have to find. Very easy. This method is very easy for finding the derivative. Hello, hello, hello. Please listen. What should we do? Read it from. Oh my God. What happened? Yeah, okay. See, what should we do here? Read it from left side. Which function you can see here? Tell me. Sine. Sine, right? Sine. Okay. So sine. No need to consider the remaining functions. Consider only the first function. Consider only the first function from the beginning. Okay. So you got here this function starting with the sine. So tell me, what is derivative of sine?
Cos.
Cos. Then remaining all you have to consider whatever things. If you have n number of functions, you consider that all as angle of that one. That is sine x. Here x square plus 1 you can consider as x as a single function. Now we have the function is sine x. Derivative of sine x is cos
Cos X.
x. Got it understood?
Yes, sir.
Okay.
Yes,
But
sir.
what we didn't differentiate here, only one function sine we differentiated, x square plus 1 we did not differentiate. That's why what we didn't differentiate, that you can differentiate in the second step, d by dx of x square plus 1. Is it clear? Okay. Which one we did not differentiate, that we have to differentiate second. Now we have final answer, cos of x square plus 1 into derivative of x square plus 1, which is 2x plus 0. You got the answer. See, 2x into cos x square plus 1, that is your final answer. Easy, right? You
Yes,
follow
sir.
this method. Okay. So I will give some questions. Try to solve it fast. Okay. Sec of tan root x. Second question. Vansh,
Yes, sir.
is it clear? Should I explain? Do you want more explanation for this?
No, sir. It's clear.
Got it. Avardhan, Krish,
No, sir.
Clear, sir.
guys, clear. Okay.
Clear.
First, you consider the given function as y is equal to, okay? Let y is equal to sec of tan root.
Six square.
Completed? Okay, just check the second question. Dy by dx is equal to, very easy. First, what we are seeing here, sec. So, what is the derivative of sec? These all things you have to, after sec, what we have, that you consider as x. So, derivative of sec x is, Avinash,
Such C T by tan T.
sec x tan x. T no need to give. No need to give t, directly you can write. Derivative of sec, these all you consider as x. So, derivative of sec x is sec x, sec x, tan x. What instead of x? Tan root x. Tan root x. Do you understand? Now, what we did not differentiate here, tan we did not differentiate. So, differentiate tan. That is d by dx of tan root x. Got it? In the second step, we can differentiate that function. So, which is equal to sec of tan root x into tan of tan root x into derivative of tan x. What is derivative of tan x?
Sec square x.
Sec square x. So, sec square x, what do you have to consider here? Root x. Is it clear? Derivative of tan x, sec square x. Here we did not differentiate root x. That's why differentiate root x. D by dx of root x. See, chain one by one we are solving. That's why we are calling it as chain rule. Now in the last you will get sec of tan root x, tan of tan root x, sec square root x. Then derivative of root x is 1 by 2 root x. If you want that, you can write in the beginning also. Okay, so just write here 1 by 2 root x. Got it. This is my answer. Anyway, you can write normally constants. You know that, right? Constants we are writing in the beginning. That's why 1 by 2 root x I have written in the beginning. Otherwise, you can write it as all divided by as you wish. No problem. Go to next question. 2 into square root of cot x square. Avardhan, ask if there is any doubt.
Yes, sir.
Okay. What about the third question? Check it. First, you consider the given function as y is equal to, so let y is equal to 2 root cot x square. Now consider 2 is a constant here. 2 is a constant. So constant you can take outside. Clear? So dy by dx is equal to constant I am taking outside, then differentiating the remaining function cot x square. Clear? Okay. Now when you approach the function, what you can see first? Derivative of what is the symbol here? Root. Clear, right? So what under the radical sign, that all you have to consider as x. Now you can read it as derivative of root x. Means square root function is there, right? Derivative root x is there, right? So that's why this you can consider as derivative of root x. What is derivative of root x?
1 by 2 root
1 by 2 root x. Instead of x we have cot x square. Got it? Is it clear? Okay. Here we did not differentiate cot x square. That's why in the next step d by dx of cot x square. Clear? Okay. 2 we can cancel. So next step, which is equal to 1 by square root of cot x square into what is derivative of cot x?
Sir, cos की जगह
minus cos
minus cos.
square x
Minus co-function, right? That's why negative. Minus cosec
cos square
x
x
square.
square.
Clear? Minus cosec x square. Now, do we have anything to differentiate?
Sir, x
X
square.
square.
X square is remaining. So differentiate x square. D by dx of x square. Minus cosec x square. Yeah. Derivative of cot, instead
Cos
of x,
square.
we have x square, right? Sorry? Minus cosec square x. Yeah. Minus cosec square x. So instead of x, we have x square. Yeah, correct. Now last derivative of x square. That is going to be the final result. So minus cosec square x square divided by root of cot x square. Then derivative of x square is 2x. If you want, you can write that in the beginning. So we will get minus 2x into cosec square x square by root of cot x square. That is final answer. Okay. Try the fourth question. Sin x square the whole square. Y is equal to sin of x square the whole square. So dy by dx is equal to, first what you can see, please tell me. In this function, what you can see first?
raised to power 10.
Very good, very good. Here it is not sine. This is of the form, see, exponential form, x raised to n, x raised to n form. So derivative of x raised to n is n into x raised to, okay, that is n is 2 here, 2 into sine x square raised to 2 minus 1. Got it? Yeah. So what we did not differentiate here? Okay. So d by dx of sine x square. Here, which is equal to 2 into 2 minus 1 is 1. So 2 sine x square right? Into
Cos x to
derivative sine x
cos x.
cos. So cos x square. Do we have anything to differentiate?
X square.
X
X
d by dx of x square. Yeah. So listen, when I differentiate x square, I will get one 2x here, right? So when I multiply this 2 into 2, it's going to be 4. Okay. Otherwise, you can do another one property here. What is 2 sine x cos x?
2
What
sin
is sine x cos x?
2 sin x. I think
Sin
sin
to
2
x.
x.
Sin
Sine to
2x.
x. Sine to x, right? Sine to x. So if you want, you can write this as 2x into sine 2x, that is x square. 2 sine x cos x is sine 2x. Instead of x, you have x square. So 2x into sine 2x square. Got it? Completed.
Yes.
Then go to the next one. If you want, just note this property also in the margin. Otherwise, later you may have confusion. Y is equal to tan of square root of sine x square. Pankaj,
Yes, sir.
is it clear?
Yes, sir.
Tell me if you need any explanation, okay?
Okay.
Sorry,
Yes.
which one? This one. This I have written here. Y is equal to tan of root sine x square. So tell me the first function when I take dy by dx. What is first? Tan x. What is derivative of tan x?
X square x.
Okay. Sec square x. X is after tan. What do you have? Square root of sine of x square. Okay. Tell me what we have to differentiate.
Root.
No, no, no. Square root of sine x square. Okay. Now sec square square root of sine x square into. Okay, tell me what is the derivative of what you can see first?
Root x.
Root x. What is derivative of root x?
1 by 2 root x.
1 by 2 root x. X is sine of x square. Now tell me what we have to differentiate?
Sine.
Sine.
Sine x.
So d by dx of sine x square. Okay. What is derivative of sine x?
It cos x.
Cos x. So cos x square. What is left over?
X square.
X square. So d by dx of x square. Derivative of x square is 2x. So sec square. Can I write directly here? Derivative of x square. Derivative of x square we will get 2x. Okay, so these two cancel. What we have remaining? 1x, right? So that x we are writing in the beginning. So we get x into, check, sec square square root of sine x square. Don't miss anything. Very carefully you write, into cos x square all divided by square root of sine
Sine.
x square. Finish. Okay.
Yes, sir.
Yeah. Now we have, these are the questions from your second exercise 5.2. Got it? Chain rule. Now let's do problems from 5.4 also. Why we are going to directly solve from 5.4? The reason is there we have a e raised to x and a raised to x property that already we have studied. Clear, right? Where we have derivative of e raised to x, we have e raised to x only. Derivative of a raised to x into log a to the base c. Okay, so these are the two properties we have in 5.4. That also we can solve first. Then we can go to 5.3. Okay,
Yes, sir.
so write the question. Question number 6. E raised to sine inverse of x. E raised to sine inverse of x. Is equal to log cos e raised to x. Log cos e raised to x. Sine inverse. Yeah, square root of e raised to root x. Okay, tell me. First, what you can see? Okay, what is derivative e raised to x? E raised to x. So e raised to sine inverse of x. Okay. Then what we did not differentiate? Sine inverse of
Sine
x.
inverse x.
What is derivative sine inverse of x?
1 by root 1 minus x.
1 by root 1 minus x square.
Yeah, 1 by root 1 minus x square over. If you want together, you can write. Means you can write in its a denominator like e raised to sine inverse of x that by square root of 1 minus x square. Okay, second one. Question number 7. Log of cos e raised to x. Avinash, tell me if there is any doubt. Should I explain once again? Avinash?
Yes, sir.
Yeah, should I explain once again this one? This one?
No, sir, not clear, sir.
Okay. Vansh, any doubt?
No, sir.
So y is equal to the given function, then dy by dx is equal to first derivative of
Log x.
Log
log
cos e
x.
raised to
What is derivative log x?
So 1 by x.
1 by x.
So 1 by cos e raised to x. Okay. Now what we have to differentiate?
So cos e raised to x.
Cos.
Okay. D by dx of cos e raised to x. Okay. After cos, you just write it in bracket. Okay, means that is the angle of cos, right? That so you just put it in bracket. That would be better. So derivative of cos x, co-function negative minus sin x, right? So minus sin e
E
raised to
raised
x
to
by cos e raised
cos
to
e
x
raised to x.
into what is left over?
Ex.
E raised to x. Okay. Now my question is, right here, can you apply any property here? Is there any
Yes, sir.
possibility to apply any
Right.
property?
So tan x.
Yes, sir. So tan x.
Tan x.
And
Okay. Sin by cos is tan. So minus tan e raised to x. Then derivative e raised to x is e raised to x. If you want, you can write this e raised to x in the beginning. So minus of e raised to x into tan e raised to x. This is also correct. They won't cut the mark. Okay. Order doesn't matter. Anywhere you can write. Okay. Next, y is equal to square root of e raised to root x. Tell me, dy by dx is equal to first root x.
1 upon 2 root x.
1 by 2 root x, that is e raised to root x. Okay. Now what we have remaining to differentiate? No. E raised to root x.
2 root x.
d by
Ex.
dx of e raised to root x. So 1 by 2 root e raised to root x into derivative of e raised to x,
E raised to x.
e raised to x. Then do we have anything?
Sir,
Yes,
root
sir.
x.
Root x.
If it is instead of root x, then no need to do. But other than x, any function you have x plus 1, x square plus 1, whatever it is, you have to solve once again that. So here it is root x, that's why differentiate root x once again. Okay. Which is equal to e raised to root x by 2 into root e raised to root x into derivative root x 1 by 2 root x. Okay. See, you can write it as e raised to root x divided by 2 into 2, 4. And listen, we have studied one property there in grade 9. What is that property?
Under root we can multiply.
What happened? Hello? Good morning, good morning. What happened? Why you did not join? No, I shared mine in WhatsApp. Okay, then join. Okay, so 2 into 2, 4. Then property is this one. Square root of a into square root of b. What is square root of a into square root of
Square
b?
root of a into b. Square root
Sir,
of a
root
into
Square
ab.
b.
root of ab. So I can write it as square root of x into e raised to root x. Clear? Okay. Sine of tan inverse of e raised to minus x. Sine of tan inverse of e raised to minus x. Arshia?
Yes, sir.
Yeah. We are going to finish chain rule. The problems from chain rule. That's what. Okay, I will explain that how to do. Write this question. Sine of tan inverse of e raised to minus x. Arshia, listen. What should we do here? The given function you can write as y is equal to, okay? Any function if you are getting, you can write that as y is equal to. So y is
Okay,
equal
sir.
to sine of tan inverse of e raised to minus x. Now you want to find the derivative of this function. So dy by dx is equal to, read it from left side. Okay?
Okay.
So when you read it from left side, first what you can see sine function, right?
Fine.
Okay. What is derivative of sine?
Cos.
Cos. Okay. So what is left over? The remaining all part you can consider as x. So derivative of sin x is cos x. X
Tan
is
inverse
e raised to minus
x.
x. Got it?
Minus.
Okay.
Okay.
Tell me, we differentiate here only sin, right? Remaining all
Yes,
things
sir.
we want to differentiate. So in the next step you can write derivative
Tan
of
inverse.
e raised to minus x. That's why we are calling it as chain rule. Okay. Connection is there.
Okay, sir.
In the next step you differentiate this function.
E raised to power minus x also.
Yeah. Means second you can see tan inverse only, right? So after differentiating tan inverse, you can go to e
Yes,
raised to
sir.
minus x. Okay. So cos of tan inverse of e raised to minus x. Okay. Into derivative of tan inverse of x. 1
1
by
upon 1 plus
X square.
1 upon 1 plus x square.
1 plus x square. What instead of x here?
E raised to
Yes.
power minus x.
E raised to x. Now we need to differentiate.
E raised to power minus x.
Yeah. So dy dx of e raised to minus x. Okay. Now my question is, listen, what is x raised to n, the all raised to n?
X raised to power m into n.
X raised to m into n. So why can't we write this as e raised to minus 2x?
Hmm.
Do you understand the logic?
Yes, sir.
Yes,
Okay.
sir.
X raised to m into x raised to m, the oldest one. So we can write x raised to m into n. So that is going to be e raised to minus 2x. Okay. So that I am writing in the next step. Cos of tan inverse of e raised to minus x, then divided by 1 plus e raised to minus 2x. Then here you have e raised to minus x. Derivative e raised to minus x is e raised to
Yes.
minus x. Okay. Okay. Then
One
Minus
by
then
x also.
okay.
Minus
You
1.
have to differentiate minus x also. Reason is what? E raised to x is the standard result. Clear? Standard function is e raised to minus x. So x is varying from anything. Means x to anything. You have to differentiate that. Here it is e raised to minus x. That's why minus x also you want to differentiate. So the final answer you will get here. Derivative of minus x is minus 1, right? Okay. So minus of this I am writing second. E raised to minus x into cos of tan inverse of e raised to minus x all divided by 1 plus e raised to minus 2x. Okay.
Yes, sir.
Just go through that and tell me if there is any doubt. Question number 10. E raised to log x plus square root of x square plus 1. E raised to log of x plus square root of x square plus 1. Okay, so how many of you know how to solve this question?
The solving.
Okay, can you say how to solve it? Any idea? Here, actually, we are using a property. Otherwise, in the normal way, traditional way, if you approach the problem, it will be so lengthy. How to solve this? See, there is a property, just note it there. That is very, very important. E raised to log x, that is x. Clear getting? Note it there in integration also, many places we are using this property. E raised to log x is x. Clear getting? Okay. So if you get these kind of problems, directly you can write this as x. What instead of x here? E raised to
X
log
was square root of x square plus 1.
x plus square root of x square plus 1. Do you understand? If you get these kind of questions, first you can just write down y is equal to this one, that is equal to what? X plus root x square plus 1. So instead of differentiating this one, what we can do? We can differentiate this function, this simple function. Getting? Come
Yes,
back.
sir.
Some rule we can use. No need to use here chain rule. Chain rule you can use in the second part, but first is sum rule we can use. When you use sum rule, derivative first function x, that is 1 plus derivative of root x, which is 1 by 2
4,
root x. Okay.
2.
Okay. Now don't put it in bracket. That will be a big blunder because here it is binomial. Second part what we have, it's a derivative only we are going to find the second part also. So this you leave it here like that and just put this one what you are going to write that in bracket. That is the product of this one. So what we have to differentiate here, dy dx of x square plus 1. Got it? Means already we find the derivative of root x. Derivative root x is 1 by 2 root x. What is left over? X square plus 1. Don't put it in bracket, this one in bracket. Clear, getting? It is, this part is only for this one. So 1 plus 1 by 2 root x square plus 1 into derivative of x square plus 1 is
2x.
2x plus 0. So 2 you can cancel from here. So the final answer is 1 plus 1 by,
X
sorry, x by square root of x square plus 1.
plus 1.
Next, 2 raised to log cos x. These are not textbook questions, okay? These are extra questions only. So practice that, okay? 2 raised to log cos x. Completed. Tell me how many of you got the answer? Once, did you get the answer?
So I got it.
Got it. Okay. What is the answer? Tell me.
So 2 log, so 2 raised power log cos x minus 1 into log cos x minus cot x.
Okay. Y is equal to the given function. So you want to find here dy by dx. So when you approach the function, we can see there's a constant here. That's why we can read it as a raised to x. D by dx of a raised to x. What is derivative of a raised to x? A raised to x into log
Log A.
a to the base e. Correct, right?
Yes, sir.
Okay. So a raised to x, that is 2 raised to log cos x into log a. A is 2
2.
to the base e. Correct, right? Okay.
Yes.
Now what we need to differentiate? Only we did a raised to x. A raised to x. So what instead of x you have, that you have to differentiate. So into d by dx. So if you want, just write this property there, the margin. Already we have written that d by dx
Yes.
of log cos x. Okay. Yeah. See, 2 raised to log cos x into log 2 to the base e. See, do you understand the position of e here? Suppose if I write that in 3 lines like this. Okay. So here you can write log 2. E you have to write here. This is the position of e. Getting log 2 to the base e or log a to the base e. This is the way you have to write. Okay. Now derivative of log x. What is derivative log x?
1 by x.
1 by x. So 1 by cos x. Now you want to differentiate cos x, right? What is derivative cos x?
Minus sin x.
Minus sin x.
Minus n. Derivative of cos x. Okay. So we get 2 log
Cos
cos x
x.
log 2 to the base e. See, derivative of cos x is minus sin x minus sin x. Getting? So sin by cos is what?
Tan
Minus
x.
Tan.
cot.
Tan
Minus
x.
tan
tan.
x.
Minus
Minus
cot x.
tan x.
Sorry,
Minus
minus tan
tan.
x, right?
Tan.
Sin by cos, tan. Okay. So that minus sign we can give in the beginning. So minus of this one, tan x you can give. This is the final answer. Minus 2 log cos x into log 2 to the base e tan x. Ayush, is it clear? Okay. Understood, right? All of you?
Yes,
Yes.
sir.
Yes, sir.
Okay. Yeah. Now you do one thing. Very, very important 2, 3 properties are there. Just note it there. Laws of logarithms, right? Laws of logarithms. Laws of logarithms. Okay. So what are the laws we are having? First one is log of AB. Okay. Log A into B can be written as log A plus log B. Got it understood?
Yes.
Base somewhere you can't see base. Okay, suppose if base is not there, that you have to consider as natural logarithm. Natural logarithm means what is that? Logarithm of a number to the base e. Okay, e means that is an irrational number like pi. Its value is 2.71828. Okay, 2.71828. So that is an irrational number, etc. is there, but we correct to 4 place of decimal there. Okay, so here something is not there, you have to understand that base is going to be e. Second property is log a by b. What is log a by b?
Log A minus log B.
log A minus log B.
Log a minus log b. Okay. Third property, log n raised to n. What is log n raised to n?
N into log
N
N.
log N.
N log n. Okay. Next is base change formula. Base change formula. Two important base change formulas are there. Log a to the base b. Log a to the base b can be written as 1 divided by
Then the
log b to the base a.
into the base.
Hmm.
Okay. Log a to the base b can be written as 1 divided by log b to the base a. And second property is very, very important. Second property, that is log a to the base b can be written as log a to the base e by log b to the base e. First one, log a to the base b is 1 divided by log b to the base a. Then log a to the base b can be expressed as log a to the base e by log b to the base e. Does it make sense, all of you? Is it clear?
Yes.
Yes, sir.
Yes, sir.
Okay. Now I will tell you one important thing. What is derivative of log x?
1 by X.
By X.
1 by x.
1 by x. Sure. So you know that derivative of log x, how to differentiate, right?
Yes, sir.
Yes,
Okay.
sir.
So
So I'll give you one question. All of you, please solve. Find the derivative of log x to the base 10. Find the derivative of log x to the base 10. Got it? What happened? How many of you got the answer? Derivative log x 1 by x, right? Then why can't you solve it?
because we have to change the base here.
Sir,
Yeah, we
minus
have to change the base.
square.
That is only for derivative of log x is equal to 1 by x. That is only when base is e, if it is natural logarithm. Otherwise, that is not going to be the answer. So what should we do? By using this base change formula, first you should convert it. How to write? This can be written as log x to the base e by log 10 to the base e. Did you get the idea?
Yes,
Okay?
sir.
Yes,
Yeah.
sir.
Now, d by dx of log x to the base 10 is equal to, listen, in this part, log 10 is a constant. Don't forget, log 10 is a constant. Constant always we have to take outside. So 1 divided by log 10 to the base e. Log 10 to the base e, you can write log 10, that is enough. Into differentiate only log x. Okay, clear? Now the answer is derivative of log x is 1 by x. So the final answer is 1 by x into log 10. This is the answer. Okay, so try this question. Log x to the base 7. Log x to the base 7. Try it. Quick. Avinash,
Yes, sir.
Avinash, do you understand? Should I explain once again?
So once again, sir.
Okay. See, Avinash, consider here base is 10, right? If e only, directly you can differentiate. Derivative of x to the base e. Derivative of log x to the base e. Derivative of log x to 1 by x, you will get the answer. But here, instead of e, we have 10. In this case, what we have to do, the last formula you have written, base change formula. By using that, you have to convert. What is the property? Log a to the base b is equal to log a to the base e by log b to the base e. By using this one, we have to convert. This is x is a, 10 is b. So how to write? Log a to the base e by log b to the base e. Understood?
Yes, sir.
Okay. Now log 10 is a constant. Constants always we can take outside. So I'm taking 1 by log 10 to the base e outside. Then what is left over? We need to find the derivative of log x. Okay. Log x to the base e is log x. Both are same. Means when the base is c, we can write that as log x. Clear? Normally we don't use
Yes,
that
sir.
one. Base we don't use there. So d by dx of derivative of log x. Derivative of log x. Derivative of log x is what? 1 by x.
By
Then
x.
1 by log 10 constant.
Okay,
Okay.
sir. Okay, sir.
Try this question also so you will get it clear. Do you finish all of you? Okay. So first, what should we do? We can write this as y is equal to. Then by using base change formula, you have to convert it. Okay. How to convert by using base change formula? Log x to the base 7 can be written as log a, that is log x to the base e by log b to the base e. That is, got it. Okay. Now log 7 is constant. We can take it outside, which is equal to 1 by log 7. Okay. Into. Now you have to differentiate log of this one, right? Clear? Don't
Yes, sir.
forget to write derivative there. Okay. Derivative. D by dx. So differentiating, right? So here also. No. After doing this one. Into log x. So differentiate. Dy by dx is equal to d by dx of these all things. Constant I can take outside 1 by log 7 into derivative of log x. We can read it as log x. Derivative log x 1 by
1 by
x.
log
X.
Then differentiate log x, right?
into 1 by x.
Into 1 by x. So the final answer is 1 by x log
Log.
x into log 7. Did you get all of you?
Yes, sir.
Yes, sir.
Yes, sir.
I didn't do one step here. You can write into d by dx of log x. In previous all questions, we have written like that. Okay.
Yes.
Okay. So this topic over. That means a chain ruler over. Okay. Now we can go to implicit and explicit functions. Should we do one combo here with the product rule?
Okay.
Should we do?
Yes, sir.
Yes, sir.
Okay. Yeah. Let's do one more question. Just write a question there. Y is equal to sine x square into cos square x raised to 4. Find the derivative of sine x square into cos square x raised to 4. First, you identify the function. Here, see, there are two functions, two complete functions. That's why you have to use product rule in the beginning, right? Getting or not?
Yes.
So, how to do? Dy by dx is equal to product rule. This is first function f of x. This is second function g of x. Clear, right? You can split it, right? Sine x square, one complete function. Cos square x raised to 4, another function. So, we solve it by using product rule only. Can you identify the functions? Is it clear, all of you?
Yes, sir.
Okay, yeah. So, what is product rule? D by dx of first function multiply with the second plus first into d by dx of second function, that is g of x. Just substitute the values instead of each one. Derivative of first function, that is d by dx of sine x square. Okay. Multiply with the second function, that is cos square x raised to 4 plus first function sine x square d by dx of second function g of x cos square x raised to 4. Clear? Okay. Now, if you want to try first function, this one, you have property. Okay. So before that, please listen, all of you. Please listen for a minute. Suppose if I give a question, y is equal to tan inverse of cos of log, okay, e raised to root x square plus 1. Got it understood? Is it clear getting? Tan inverse of cos of log of e raised to root x square plus 1. That's a function. Okay. So listen, without taking step-by-step calculation, how can we find in a single step? How can we find the solution in a single step? Chain rule is very easy. If you understood the thing, then it is very easy. So how to write? See, very easy. Without simplifying, I am going to write this. First derivative of tan inverse of x. What is derivative of tan inverse of x? 1 by
1 by root
1 plus x square, right?
yes,
Yes,
So cos of log of e raised to root x square plus 1. Getting? Okay. Then second function cos, derivative of cos x, that is minus sin x. So minus of sine, clear, log e raised to root x square plus 1. Okay. The next tan complete, tan inverse completed, cos completed, next log. Derivative of log x 1 by x, that is 1 by e raised to root
root x square
x
plus
square
1.
plus 1. Okay. Then derivative of e raised to x. Derivative of e raised to x is what? E raised to root x square plus 1. Okay. Then we have root x. Derivative of root x is 1 by 2 root x square plus 1. Then we have x square plus 1. That is 2x plus 0. Do you understand?
Yes, sir.
Simple, right? Easy, right? One by one you have to solve, you will get the final answer. So why I am telling that, if you have these kind of questions, it is so lengthy when we do step-by-step calculations like that. So directly you can write here where we have compositions. Getting? For individual questions we can solve, you can simplify that in the same as we solved earlier. But here if you have these kind of combos, but in a single step you have to simplify that. That is derivative sine x square. So first we can say derivative, it's a composition, right? Sine x is standard function, but x is varying from x to x square. That is composition. So derivative of sine x cos x square. Clear, right? Cos x. Then differentiate x square, you will get 2x. Do you understand this one, all of you?
Yes,
Yes,
sir.
sir.
Okay. Otherwise, if here, suppose you are going to solve into d by dx of x square, it will be solving b. That's why I have written like that. Okay. Then multiply with the cos square x raised to 4 plus sin x square into derivative of, see, cos square x raised to 4. So first what you can see here, this separately I will do here. Okay. See, y is equal to cos square x raised to 4. How to solve?
2 cos x raised to power 4.
Exactly. Very good. See, sometimes you may think that here there is nothing, any other no functions are there, so we can start with the cos. If you start with the cos, your answer will be wrong. Why? Cos square x raised to 4 for trigonometry functions, especially cos square x raised to 4 is cos x raised to 4 the whole square. This is exponential form only. Clear, right? Okay, so that's why what should we do? You have to first x raised to n property apply. So derivative of x raised to n, that is n into x raised to n minus 1. So 2 cos x raised to 4. This is the first one. Then differentiate cos. derivative of cos x minus sin x raised to 4. Then x raised to 4, that is 4x cubed. Is it clear? Got it?
Yes, sir.
Okay. By combining these two things, all of you please check. This is of the form 2 cos x sin x. Leave minus sign. What is 2 sin x cos x?
Sin
Sine 2x.
2x.
Sin 2x.
Sin 2x. So I can write sin 2 x raised to 4. Did you get the idea? With this minus 4x cube also. Can you see?
No, sir.
No, sir.
See? Okay. So 2 sin x cos x I am writing sin 2x. So sin 2 x raised to 4. Okay. 2 sin x cos x sin 2x. Then we have minus 4x cube left over. That was I am writing. Minus 4x cube. Clear?
Yes, sir.
Okay. Those who have any confusion, separately in the margin, the normal case what we solved earlier, the same way you differentiate that one. Okay. Chain rule. Then substitute the value. You know that, right? How to simplify this? Means if you get these kind of individual questions, first you take cos x raised to 4 the whole square, that is of the form x raised to n. Then we get 2 cos x, 2 cos x, then derivative of cos x minus sin x, then x raised to 4, that is 4x cubed. And to sin x cos x we are writing sin 2x. Avinash, is it clear?
Yes, sir.
Got it. Our then
Yes, sir.
yeah. Ayush, got it. Okay. Yeah. Vansh, Krish, Arshia,
Yes,
got it
sir.
right? Okay.
Yes, sir.
Pankaj,
Yes, sir.
got it? Should I explain once again? Any step?
No, sir.
No, sir.
No, sir.
No, sir.
Okay. So final step you can write. Do we have check anything? Can we write anything outside? Can you write anything outside? If you want 2x, we can take outside, right? 2x.
Yes, sir.
Only 2x is there. Okay. Otherwise, that doesn't matter. Directly you write 2x cos x square into cos square x raised to 4 minus 4x cube sin x square into sin 2x raised to 4. Got it?
Yes, sir.
Okay. Now let's go to the next part. See, today what you have to do when you prepare for your examination, you just go to that all the exercises, continuity, first exercise. From the exercise, if you are facing any difficulties, tell me that. Then second 5.2, 5.3, 5.4 like that. Okay, all the questions you have to solve from that, including exam questions. Now nowadays, what you have to do? Suppose if you are not giving that much consideration to your the coming pre-board examination. For board examination, how we are practicing the same way, complete topic you have to cover. Got it? Read the textbook also. Okay. Whatever it is, you should attend the examination. Okay, means you are getting an opportunity to uh, face the like board examination, right? The same pattern you are going to write. So maximum exam you have to write whatever it is. Okay, and logically think what answer you have to write. Don't skip any question. Maximum try to attend all the questions. Time management is all you have to what? Just note it down. Yeah, come on. Next, right? Next, derivatives of implicit functions and trigonometric function, inverse trigonometric functions. Derivatives of implicit functions and inverse trigonometric functions. Okay, so inverse trigonometric functions already you have seen. Derivative of sine inverse of x, that is 1 divided by what? Square root of 1 minus x square. Then cos inverse, tan inverse, these all we have written that. What is implicit function and explicit function? That I am going to explain now. Okay, just give a small heading. Explicit function. Explicit function. Do you know what is explicit function? Explicit function. Simple. These all functions, earlier what we practiced, that all functions were in the form explicit. Clear? That means if you can write any function directly y is equal to f of x, that function is called the explicit function. Just note it there. A function of the form or a function of the type y is equal to f of x is called the explicit function. Note it there. A function of the type y is equal to f of x is called the explicit function. Next is implicit function. What is implicit function? Easily you can identify if in the given function, see what is explicit? Y is equal to f of x, which means in the function you have only one variable, x. But easily you can identify implicit function. In implicit function you will have two variables, x and y. Do you understand? In the given function you will get two variables, x and y. That kind of functions are called implicit functions. That is a function of the type f of xy is equal to any constant. Clear, getting? Any function of the type f of xy is equal to c is called an implicit function. Note it there. Any function of the type f of xy is equal to c is called an implicit function. Okay. Write the question, you will get it easily. Find dy by dx in the following. Right. Find dy by dx in the following. Okay. First part you understood, right? All of you? Chain rule?
Yes.
Clear. Okay. After chain rule, we have implicit and explicit function. So how to simplify implicit and explicit function? Just consider this question. Previous all questions you got the function in terms of only one variable, but here you have in terms of two variables, see x and y. So you understood that this is an implicit function. So how to find the derivatives of implicit functions? See, to find the derivative of implicit function, what we have to do? Differentiate both sides with respect to x. Differentiate both sides with respect to x. That is only the difference. Getting? Okay, so right. Differentiate both sides with respect to x. Differentiate both sides with respect to x. Differentiate both sides with respect to x. Yeah. Okay, now please listen for a minute. Please listen for a minute, all of you. See, some rule we can apply here. So first derivative of 2x, 2 we are taking outside, derivative of x, that is 1. Correct, right? Okay. Plus Okay, see, listen, before going to do that, d by dx of x square. Tell me the answer.
2x.
So 2x.
2x.
X.
2x. Any doubt? Any confusion?
No,
No,
sir.
sir.
Okay. D by dx of y square. What is derivative y square?
2y
2y
into dy
into dy
by
by
dx.
dx.
Ah,
Dx.
yeah. Not only 2y, then we have to differentiate y also. The reason is when we started
dy by
today's class, I told you these variables are same, then we can completely differentiate. Otherwise, that variable also you have to differentiate. See here x, here it is y. So first you have to apply the property derivative x raised to n, that is 2y. Then differentiate variable also. Variable is y, so dy by dx. Getting understood? This you don't forget. Okay? Yeah. So here how to write x, first 2x we differentiated. Now we have 3y. So 3 constant we are taking outside. When you differentiate y, dy by dx. That is equal to derivative of sin x cos x. What is the question? Read the question.
find dy
Find
by dx.
dy by dx.
dy by dx. Okay. So leave dy by dx here. Remaining all you can transpose. So 3 dy by dx is equal to cos x minus 2 dy by dx is equal to cos x minus 2 divided by 3. Easy, right?
Yes, sir.
Yes, sir.
Yes.
Okay.
Yes.
Write the next one. Xy plus y square is equal to tan x plus y. Xy plus y square is equal to tan x plus y. Hello? I told you 10 to 12, right? But we started at, I think, 10:20. Is there any problem if I continue till 12:30?
No,
No,
Okay.
No,
sir.
sir.
You understood, right? This one is implicit. X and y, two
Yes.
variables are there. Okay. So, method is differentiate both sides with respect to x. How many of you got it?
Yes.
Differentiate both sides with respect to x. So, d by dx of xy plus y square is equal to d by dx of tan x plus y. Right? Okay. Now, some rule. But consider the first one x into y, right? So, here you
yes.
should use product rule. D by dx of xy. Okay? Plus d by dx of y square. That is equal to, here directly you can do derivative of tan x is sec square x plus dy by dx. Okay, see, if I do this part, I have to use product rule. Product rule. What is product rule? Derivative first function, that is dx by dx into second y plus first x into derivative of second dy by dx. Got it? Okay. x into y, right? That's we apply product rule. Plus here derivative y square. Earlier we discussed the same thing. 2y variable, see x y, that's why differentiate y also dy by dx, which is equal to sec square x plus dy by dx. What is question? Question is find dy by dx. So from all these terms where we have dy by dx, that all you group it and bring it in the same side. Okay. So first dx by dx is 1. So 1 into y plus x dy by dx plus 2y dy by dx. Okay. This dy by dx I am bringing left hand side. So minus dy by dx, that is equal to sec square x. In all these three terms we have dy by dx. So what should we do? This y we have to transpose in the other side. Y I am taking on the other side. And from these three times dy by dx I am taking outside. So when I take dy by dx outside, here you have only x, here you have 2y, here nothing is there, that's why minus 1. Don't write 0 there. 0 into dy by dx is 0, right? So that time vanishes. That's why consider the coefficient of every number as 1. 1 is there. This is why we are taking right hand side. So sec square x minus 1. Okay. Check carefully and tell me any step is not understanding. Now question is find dy by dx. So dy by dx is equal to
Once again, last
the,
step, sir.
sorry,
Last step, sir. How do you minus one? How, sir?
yeah,
Minus y will
Minus y will be there, na?
minus y.
X square x
yes
minus
sir.
y.
Okay. Y. Yeah, correct. Not 1, y. Yes. Divided by x plus 2y minus 1. Here only we have 1. Means dy by dx we are taking outside. That's it. Do you understand? Did you get how to solve it?
Yes, sir.
Yes.
Okay. Next question. Sine square y plus cos xy is equal to pi. Sine square y plus cos xy is equal to pi. Come on, try. Got it? See how to write implicit function. That's why differentiate both sides with respect to x. Okay.
Yes.
So d by dx of these all things, that is equal to d by dx of pi. Derivative of pi, you know that pi is a constant, that's why 0, right? Derivative of constant is 0. Left side, see d by dx of sine square y plus d by dx of cos xy. Okay. Not cos x into y, cos xy. Clear? Okay. So first derivative of sine square y. It is of the form sine square y is sine y the whole square. That's why x raised to n form, right? So derivative
Yes,
x
sir.
raised to n is tell me
2 cos y.
So to
2
sign
sine y.
I
Okay. Into then you have to differentiate sine y. Derivative sine y
Cos y.
cos I
cos y. Then differentiate y also.
divide
Here variable x,
dy
right?
by dx.
dy by dx. How many of you got this one? Tell me.
yes sir.
Okay, good. Okay, yeah. Now plus derivative of cos xy. What is derivative of cos xy?
Minus sin xy
Minus sin xy. Then
dy by dx.
dy by dx.
uh-huh.
Right?
Product
dx
rule.
by
Dr. Rule, sir.
D by dx of xy. Product rule. We differentiate only cos, right?
Yes sir.
Okay.
Yes,
So
sir.
product rule. Don't forget that. Okay. Product rule you have to apply there. So 2 sin y cos y, that is sin 2y dy by dx. Okay. Then minus sin xy into product rule. Derivative of x1 into y plus first function x into dy by dx. That is equal to 0. Avinash, any doubt?
No, sir.
Okay. Derivative of cos minus sine. Angle x to x into y, right? Product. That's why when we approach xy, you have to solve it by using product rule. Derivative xy. Now next step, sine 2y into dy by dx. Okay. See, minus this one into bracket. So minus y into sin xy. Okay. Then minus into plus minus x sin xy dy by dx. That is equal to 0. Now check all those terms contain dy by dx. First and last. So from these two terms, dy by dx we can take outside. And this you transpose. So dy by dx into, in the first term here you have sin 2y minus here x sin xy. That is equal to right side y sin x. Got it? No, nothing is there. Just transpose this term. You will get the final answer. Did you get the final answer?
Yes, sir.
This you transpose. dy by dx
Yes, sir.
is equal to y sin xy by sin
Sine
2y
2.
xy. Clear, right? Okay.
Yes,
Yes,
sir.
sir.
Do you understand all of you how to solve implicit functions? Easy, right?
Yes.
Differentiate
Yes, sir.
both sides with respect to x. dy by dx you take outside, express in terms of dy by dx. That's going to be the final answer. Okay. Now let us check how to find derivative for inverse trigonometric function. Okay. Okay. So just give a subheading: derivatives of inverse trigonometric function. Right there. Find dy by dx in the following. Find dy by dx in the following. Y is equal to sine inverse of 2x divided by 1 plus x square. Okay. See all of you. Listen. Uh, if you write directly, d by dx of these functions as derivative of like this derivative of sine inverse of x, that is equal to dy by dx is equal to derivative sine inverse of x is 1 divided by square root of 1, right, 1 minus x square.
Minus
So 2x divided by 1 plus x square the whole square. Then differentiate dy by dx of 2x divided by 1 plus x square. This is a tedious process. It's very lengthy. Getting understood?
Yes,
Okay.
sir.
So you don't follow that method here. Okay. You don't follow that method here. That is a tedious process. So how to solve it? Okay. See all of you. Do you know algebraic forms of trigonometric functions? Do you have any idea? Algebraic forms of trigonometric functions.
no, sir.
No idea. Okay. So listen here. Just note it there. This will be an easy tip for you to simplify questions not only from this one, both the integration and inverse trigonometric functions. Okay. So what are the forms you are having? Just note it there. See, you know that sine square x plus cos square x is equal to 1. Clear, right? Okay. From this, either sine square x or cos square x, you can express it as 1 minus cos square x or 1 minus sine square x. Is it clear? That means algebraic form of this one is 1 minus x square. Anywhere if you get 1 minus x square, what do you have to understand? X is either sine or cos. There are two possibilities. Getting?
Yes,
Understood?
sir.
Yes, sir.
Do you understand the algebraic form? Okay. Next, the same way, sec square x minus tan square x is equal to 1. Then sec square x is equal to 1 plus tan square x. Okay. So the same way, cosec square x minus cot square x is equal to 1. From this, cosec square x is equal to 1 plus cot square x. That is, if you have 1 plus x square form, 1 plus x square form, either x is tan or cot. Got it? Is it clear?
Yes, sir.
Okay.
Yes, sir.
Yeah. Next, what you have here, I can write it as sec square x minus 1, that is equal to tan square x. The same way, from this you will get cosec square x minus 1, that is equal to cot square x. So if you have these two forms, that is x square minus 1, this is 1 minus x square. If 1 minus x square is there, either sine or cos, that is possibility. 1 plus x square tan and go to x square minus 1 sec and cosec. Okay, note it fast. Q. Write algebraic forms. Speed up. Tell me once you get finished, okay?
Done, sir.
Then completed. Okay. Yeah. Next one. This one. See, cos 2x is equal to, what do you have? 2 cos square x minus 1. Okay. So this is of the form 2x square minus 1. Note it there. Then next one is 1 minus 2 sine square x. This is of the form 1 minus 2x square. So x is going to be sine x. Okay. Next is 1 minus tan square x divided by 1 plus tan square x. Okay. So this is of the form 1 minus x square by 1 plus x square. If you have this condition, what you should do? You can write what? Tan x is equal to tan x. Got it? Or tan theta. Don't write tan x, tan theta. Next, sine 2x. Sine 2x is 2 sine x cos x. So this one you are not expecting what we are going to get. The form of this one is 2x into square root of 1 minus x square. I think you got it. See, listen, I will tell you. 2 sine x cos x. I can write this as 2 into sine x into cos x can be written as square root of cos square x. Correct, right? Got it? Which can be written as 2 sine x into square root of 1 minus sine square x. So what? It is of the form 2x into square root of 1 minus x square. X is going to be sine x. Either sine or cos. Two possibilities are there. Either sine or cos. So if you get this property, what do you have to understand? This is 2 sine x cos x. Clear? Okay. Next, one more property is there for it. That is 2 tan x divided by 1 plus tan square x. Okay. So this is of the form 2x by 1 plus x square. Please check it all of you. Our given question. 2x by 1 plus x square form. So x is going to be, what is
Tan
x?
x. Tan y.
Not tan x, tan theta.
Tan theta.
Tan theta. Okay. This should be another one variable. Okay. Yeah. Next, tan 2x is equal to 2 tan x divided by 1 minus tan square x. Both are look like same, but a small difference is there. In the denominator, it is minus. Completed.
Yes, sir.
Next one is sine 3x. What is sine 3x? 3 sine x minus 4 sine cube x, right?
Yes, sir.
Yes, sir.
Okay. So 3x minus 4x cube. cos 3x, 3 cos cube x minus 4 cos x, right? So 3x cube minus 4x4.
Hello.
Hello? Yeah.
Sir,
Pankaj?
cos 3x properties है. Once again check.
Cos 3x, 3 cos cube x minus 4 cos x.
Sir, it is 4
Don't
4 cos
So
cube x
4 cos cube
minus
x minus 3 cos x.
cos x.
Sorry. Yeah, correct. 4 cos cube x minus 3 cos x. Yeah, right. 4 cos cube x minus 3 cos x. Yeah. So 4x cube minus 3x, right? Next, tan 3x, 3 tan x minus tan cube x divided by 1 minus 3 tan square x. That is going to be 3x minus x cube divided by 1 minus 3x square. So what you should do today when you practice questions from inverse trigonometric functions, you just go through this property, algebraic forms, you will get it easily. Questions are of these types only. Have you ever noticed that?
Yes, sir.
Example questions, exercise questions are of this type only. 4x cube minus 3x or 3x minus 4x cube, like that only. Okay, so what you have to understand, if it is 4x cube minus 3x, x is going to be cos x only or cos theta only. Okay, so these are the properties you want to cover. Okay, now let's solve problems. Can I clear this? Okay, go to this question. Y is equal to sin inverse of 2x divided by 1 plus x square. Okay, so tell me which algebraic form is given. Identify that.
2 tan theta upon 1 plus tan square theta.
Okay, very good. 2 tan x divided by 1 plus tan square x form, right? So what do you have to consider as x? X is equal to
Tan theta.
tan theta. Very good. Right. Let x is equal to tan theta. The important thing you have to note is that when you define x, immediately you have to define theta also. When x is equal to tan theta, then what is theta?
Tan inverse of x.
Tan inverse x.
Very good. Tan inverse of x. Good. Okay. Now you substitute the value there. Y is equal to sin inverse of 2 tan theta by 1 plus tan square theta. That is equal to sin inverse of, tell me,
Sin 2 theta.
2 tan theta by 1 plus tan square theta is
Sin 2 theta.
sin 2 theta. Okay. See, what is sin inverse of sin x?
X.
X.
X. This you have studied right in second chapter. Sin inverse of sin
Yes,
x is
sir.
equal to x. Sin of sin inverse of x is equal to x. Okay. So sin inverse of sin 2 theta is 2 theta. So 2 into theta you got
X.
Tan inverse of x.
tan inverse of x. So see, very simple. Y is equal to sin inverse of 2x divided by 1 plus x square is equal to 2 tan inverse of x. Now what do you want to find? Dy by dx. So dy by dx is equal to 2 into
2 into
derivative tan inverse of x.
1 by 1 plus x square.
1 by 1 plus x square.
Easy. Got it?
Yes,
Yes,
sir.
sir.
Okay. Come on, try it all of you. Next one. Y is equal to tan inverse of 3x minus x cube by 1 minus 3x square. Try yourself. The same way. Simple question. Completed.
Yes, sir.
Yes, sir.
Okay.
Yes,
So
sir.
which algebraic form is this one?
Tan
And 3
3 theta.
dx.
Yeah. 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta, right? So x is equal to, let x is equal to what? Tan theta implies theta is equal to tan inverse of x. Both the things you have to define first. Therefore, y is equal to tan inverse of 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. Don't write x, okay, already x is there. That's why you can give either theta or phi, another one variable, or p, something like that, okay? Yeah, which is equal to tan inverse of, you know that this formula, this gives tan 3 theta. Okay, so tan inverse of tan 3 theta, 3 theta, right?
Hmm.
That is y is equal to 3. Theta is tan
Tan
inverse of
inverse.
x.
Tan inverse of x.
Okay, we need to find dy by dx. So dy by dx is equal to 3 into 1 by 1 plus x square,
1
or
plus
3
x.
by 1 plus x square. Easy, right?
Yes, sir.
Okay. Y is equal to sine inverse of 1 minus x square by 1 plus x square. Next question. Y is equal to 1 minus sine inverse of 1 minus x square by 1 plus x square. Did you complete all of you? Which property is this one? Tell me. Which property, which identity is this?
Theta.
Cos.
Cos
Ah,
2
no,
theta.
no, no, no,
Cos
no.
theta.
Cos 2 theta. 1 minus tan square x divided by 1 plus tan square x, right? That is
Yes.
cos 2x. Okay. So you can take x is equal to tan theta. So theta is equal to tan inverse of it. So y is equal to sine inverse of 1 minus tan square theta divided by 1 plus tan square theta. Okay. So y is equal to sine inverse of, this is cos 2 theta. My God, what we will do? See, sine inverse of cos, sine inverse of sine only we can write. Yes or no? Or cos inverse of cos only we can write like that, means it 2 theta. But here it is sine inverse of cos. So what should we do? Simple. What we have to do? Any idea?
Sin pi by 2 minus 2
1
theta.
Very good. 90 minus theta, right? Sine pi by 2 minus theta is what? Cos theta. So cos 2 theta can be written as sine 90 minus theta. That is y is equal to sine inverse of sine pi by 2 minus 2 theta. Check it. Sine pi by 2 minus 2 theta is what? Cos 2 theta. Now we have in terms of sine inverse of sine theta. After sine, whatever things we are having, that all are theta only. So sine inverse of sine theta. So sine inverse of sine theta is what? Theta. Pi by 2 minus 2 theta. Now theta you have to substitute here. y is equal to pi by 2 minus 2 tan inverse of x. dy by dx is equal to pi by 2 is constant, derivative constant is 0 minus 2 into derivative tan inverse of x 1 by 1 plus x square. So final answer is minus 2 by 1 plus x square. Okay, last question.
Sir,
Yeah, tell me.
so can't we take pi by 2 plus 2 theta
Pi by 2.
plus 2 theta?
How can we take pi by 2 plus theta? Pi by 2 sine pi by 2 plus theta, right? Sine pi by 2 plus theta, that is going to be in second order here, right? Okay. Sine 90 plus theta is cos theta. Ah, okay, you can consider.
Okay, sir.
So then the answer will be 2 by 2 upon 1 plus x square.
2 by 1 plus x square, yeah. When you take the integral, right, this is actually derivative, right? Slope of the tangent, see, you have two conditions, right? See, d by dx of sine inverse of x, that is equal to 1 divided by 1 plus x square. D by dx of cos inverse of x, that is equal to minus 1 by, sorry, square root of 1 minus x square, minus 1 divided by square root of 1 minus x square. Okay, so if I want to find the original function, that means a primitive antiderivative. So integral of 1 divided by square root of 1 minus x square, clear? That is equal to two possibilities are there. Either what? Minus, sorry, sine inverse of x or minus cos inverse of x, correct, right?
Yes, sir.
Is it right? Co-function, right? So depends upon the function, negative or positive it will get. Clear, understood?
Yes, sir.
Do you complete all of you?
Yes, sir.
Okay.
Yes, sir.
See, in some of the questions, you may get restrictions there, okay? You know that in the bracket you have minus 1 by root 2 less than x less than 1 by 2, that kind of restrictions are there, right? So always you check the restriction. If restriction is not given, these kind of any values you can write. Either you can write in terms of sine inverse of x or cos inverse of x, you can write. But if restriction is given, only on the restriction you have to write. You have to check the values, which one is satisfying in that particular restriction. Got it? Is it clear? Okay. Otherwise,
sir.
both the solutions are possible there. But in most of the questions, they will give restrictions. In test 2 questions also, restrictions are there. Okay.
Okay, sir.
Sine inverse of 2x into square root of 1 minus x square. Come on, try it fast. This already we discussed it. How to write it, which property you have to take. Got it?
Yes, sir.
Which property is this one? 2 sine x cos x, right?
Sine 2 theta.
Okay, sine 2 theta. Okay, so take x is equal to sine theta. So theta is equal to sine inverse of x. Got it? Then y is equal to sine inverse of 2 theta is, sorry, x is sine theta into square root of 1 minus sine square theta. That is equal to sine inverse of 2 sine theta cos theta, right? Square root of 1 minus sin square theta, cos square theta, square root of cos square theta, cos theta. So sine inverse of sine 2 theta. Getting? Sine inverse of sine 2 theta is 2 theta. That is equal to 2 into sine inverse of x. This also consider, suppose if restriction is not there, you can take x is equal to cos theta also there. You will get the same solution, negative and positive, same as the previous one. But you check there, okay, when you take x is equal to sine theta or cos theta, in the restrictions are we getting the values there? Okay. Then dy by dx is equal to 2 into derivative sine inverse of x, 1 divided by square root of 1 minus x square. Clear? Should we do one more
Yes, sir.
question?
No, sir.
Yes,
Enough.
sir.
Okay, just try. Last question. Sec inverse of 1 by 2x square minus 1. Last one. Come on, try. Can I clear this?
Yes, sir.
Ayush? Do you complete? Okay. Completed.
Yes, sir.
Okay. See, check here. Which trigonometric ratio you will consider?
Cos 2
Cos
theta.
theta.
Sir, cos.
Very good, very good, very good. 2x square minus 1, right? 2x square minus 1 is 2 cos square minus theta. Clear, right? There is only one condition is there. So you can take x is equal to cos theta, right? Then theta is equal to cos inverse of x. Okay. Understood? Do you understand how to identify the property from algebraic expressions? Clear? Okay. Here, y is equal to sec inverse of 1 divided by 2 cos square theta minus 1. That is equal to sec inverse of 1 divided by 2 cos square theta minus 1 is cos 2 theta. Right? 1 by cos is sec. So 2 theta. Okay. That is y is equal to 2 cos inverse of x. So dy by dx is equal to minus 2 divided by square root of 1 minus x square. Okay. Clear? Completed
Yes,
all of
sir.
you. So tell me if there is any doubt.
Sir.
2 by 1 root 1 plus x square.
Sorry? Minus, right? Cos inverse of x, right? Co-function negative, right?
But theta, we can see the sine theta.
Sorry?
Check once again.
Cos
Theta
theta.
is equal to cos inverse of x, right? So derivative of cos inverse of x is minus 1 divided by square root of 1 minus x square, right?
But if we take x equals to sine theta, then we get an answer.
No, we cannot take x is equal to sine theta. How can we take? See, this is of the 2x square minus 1.
Got it. I did
If it
wrong.
is 1 minus 2x square, you can take x is equal to sine theta, right?
I take by that way, sir.
Okay. It is 2x square minus 1, right? So check the properties. Cos 2 theta is equal to cos square theta minus sine square theta, or 2 cos square theta minus 1, 1 minus 2 sine square theta, 1 minus tan square theta divided by 1 plus tan square theta. So in this form, we have 2 cos square theta minus 1, right? So x is equal to cos theta. Clear? Pankaj,
Yes,
is
sir.
it clear? Okay.
Yes.
Okay. So all of you, thank you so much.
Thank you,
Practice
sir.
very well and write tomorrow's exam. Well, okay. Maximum try to score full mark. Okay.
Yes.
Wish you all the best. See, what is the problem actually? evening sometime I will have a meeting at the 3 o'clock. Now their pre-board exams are going on. Okay, so that's why I told you right now I am an academic coordinator. That's why. So might be sometime I have what some meeting or something. I can't take evening class. That's why I extended till this
No
time.
problem,
Okay,
sir. I also have to
okay.
go to
So,
marriage.
so if I am free, I will means at least 1 or 2 hours before I will schedule it. Okay,
Okay, sir.
get it? Okay.
Okay,
So
sir.
all the best. All of you. Thank you.
Thank you, sir.
बस सर
Bye.
Bye,
Bye.
sir.
थैंक यू सर।
धोनी, हेलो, जल्दी जा, जल्दी करण को देना, जल्दी।
क्या हुआ?
पहले
ओए करण को फोन दे दिया ना आपने?
ये मेरा फोन था यार, वो तेरे को क्या बताऊं मैं
नहीं
यार।
करण का फोन था, तेरा फोन था?
मेरा फोन था, तेरे को बाद
मेरा
में
फोन था।
बताऊंगा। धोनी बाहर जा,
जा बोल
कह रहा हूँ कि
बोल।
करण को लेने जा जल्दी, पहले वो कब का वेट कर
भाई
रहा, फिर मेरे को लेने आना जल्दी।
मैं तो शर्ट के बिना पढ़ रहा था।
क्या
हमारे
हुआ?
सारे बोलते कैब
क्या
बुक कर।
हुआ?
करण को लेने जा जल्दी।
क्यों?
क्यों यार, बाद में चंडे वो यहाँ पे आएगा, जल्दी बोल।
ओ बुखार पड़ गया।
जल्दी जा,
आ रहा आ,
जल्दी
आ
जा,
रहा पता है क्या आ रहा हूँ।
जल्दी जाना, जल्दी पहले करण के घर जा जल्दी।
ओ क्रिश, ओए बात सुन ना क्रिश।
हाँ हाँ, बोल।
कल का पेपर पढ़ के दे रही हो, ऐसे ही दे रही हो बेकार टाइम पास?
मैं ब्याह पे जा रहा हूँ यार शाम को, तू जा।
मैं भी ब्याह पे आ रहा हूँ। क्या वो चिटवाल
चल,
पम्प्स?
ब्याह में चलेंगे, हाँ।
चिटवाल?
आहो।
ओ मेरे को ही बुलाया हुआ है उधर।
नहीं
नहीं
नहीं।
चौधरी है वो, कुछ चौधरी है वो। पंकज के क्या बोलते हैं, भाई लगता है। पंकज का दूर पर से भाई लगता है वो लड़का। उन अंकल का
हाँ,
नाम है वो, क्या बोलते हैं, शिवम के मले में रहते हैं अंकल।
आंटी का नाम पता है? हाँ
अंकल का
हाँ।
नाम मुझे पता है। अंकल का निक नेम पता है मेरे को।
ठीक है भाई।
मैं तो आऊंगा। ठीक है फिर बाय।